So we started topic one, which is about the formulas, equation, and amount of the substance, or you can also say modes. And these are the learning objectives. So first, yesterday we started with a definition of the mole. It's amount of substance which contain Avogadro's number of the particle. That's called mole. Relative atomic mass is average mass of one atom compared with the 1/12 of mass of the carbon atom. And the molar mass is the mass of one mole, which is expressed in gram. We call that as a molar mass. And we discuss some examples related to using a formula, finding the moles, if the mass is given, if the volume is given, and if the concentration and volume are given. Then we work out the number of the particles using the moles. And today we'll discuss the general gas equation, and that equation is PV is equals to nRT. So when PV is equals to nRT, this equation is known as the general gas equation. But what is the meaning of P? P stands for pressure, and that should be in Pascal. The SI unit of pressure is Pascal or Newton per meter square. V is the volume, and that should be in cubic meter or meter cube. N is the number of the moles of a gas. R is called a general gas constant or ideal gas constant, and it is having a value of 8.31. So it's a fixed, it's a constant. And what is T here? T is the temperature, which should always be in Kelvin. But in what condition you will use this equation? For example, if a gas is given and conditions are not room temperature, like we have the formula that moles equal volume of the gas. So moles equal volume of the gas divided by 24. That is a formula, and that is the volume of gas in dm cube divided by 24. This is a formula normally we use, but there's a condition for this, that this formula is valid when the temperature is around 25 degrees centigrade or 298 Kelvin, and the pressure is 1 atm, which is also equal to 100,000 Pascal. But what if the conditions are not 25 degrees centigrade or 298 Kelvin and the pressure is not 1 atm or 100,000 Pascal? So if the conditions are not same, then we have to use this formula PV is equals to nRT to find the either any unknown. We can use it to find the volume or to find the moles depending on the question. And always keep in mind that pressure is in Pascal, volume should be in cubic meter, and the temperature should be in Kelvin. So we'll do some questions now related to this part. So this is an assignment related to moles. So the question is, how many protons, neutrons and electrons are there in a chloride ion? So what could be the right answer? You have a chloride ion. Chlorine is 35, 37 and 17, and with a charge -1. A is the atomic mass, which is 37 or mass number or nuclear number, and Z is equals to 17. To find the number of protons, that is given by Z, to find the number of neutrons, that is A minus Z, and to find the number of electrons, that is Z minus the charge. So how many protons are there? The number of protons are given by Z, so that is 17. Number of neutron A minus Z, so 37 minus 17, that is equals to 20. And number of electrons Z minus the charge. So Z is 17 minus, and the charge is -1, so it will come out as 18. So it should be 17 20 and 18. So C should be the right answer for this. Is it clear? As it is a negative charge, so the number of electrons should be more than number of protons. What is the relative formula mass of hydrated barium hydroxide dot 8H2O? So how we can work out the mass? The barium, the elements which are present, barium is there, oxygen is there, hydrogen is there, and then hydrogen and oxygen. So that is about the water. So barium is 137.3 plus oxygen is 16 multiplied by 2 plus hydrogen is 1 multiplied by 2 plus 8 water molecules are there, and each water molecule the mass 2 plus 16, that is equals to 80. So that is multiplied by 80. So when we solve this, it will come out as 315.3. So D will be the right answer. In question 3, 11 gram of a sample of anhydrous sodium sulfate dissolve in deionized water to form 70 cm cube solution. What is the concentration in mole per dm cube for aqueous solution which is formed? So to get the concentration, the formula which we use to calculate the concentration is moles divided by volume. But we don't have the moles, we have the mass. So formula to calculate the concentration is equals to moles divided by volume. What about moles? Moles equal mass in gram, which is 11 divided by molar mass. The molar mass of sodium sulfate relative molecular mass is given 142, so this will be 142.1. So 11 divided by 142.1. What's the answer for this? Yes, Abdullah and Saleh. 11 divided by 142, 0.077. So moles here are equal to 0.077. And about the volume, as the volume is given in 70 cm cube, we have to convert the volume of in cm cube into dm cube. So when we want to convert the cm cube into dm cube, we divide by 1000. So it should be 70 divided by 1000, which is equals to 0.07 dm cube. Now to get the concentration is moles divided by volume. So moles are 0.077 and the volume is given 0.07. So 0.077 divided by 0.07, that will give us 1.1. So the concentration will come out 1.1 moles per decimeter cube. So C will be the right answer for this. Is it clear? Discussion. Another question. This is related to salt. Now we will do some question related to the equation PV is equals to nRT. So in this question, and you don't have to memorize this equation, you can clearly see that in the question they provide you the equation for PV is equals to nRT. So what they mention, ethene is used commercially to speed up the ripening of bananas. Ethene level is 100 parts per million. That's a unit of concentration. Like if you have 1 million particles, you will find 100 parts of ethene. Calculate the amount in mole ethene which is ripening a room of volume 220 meter cube at a temperature 21 degrees centigrade and a pressure 1.01 exponent 5. Give your answer to appropriate number of significant figures. So first, what we do, we'll find that because a room contains particles, okay, air is there, and out in this air, out of 1 million, only 100 parts are there for ethene. Like if you have 1 million molecules, out of 1 million molecules, you will find only 100 molecules are ethene molecules. So first what we do, we'll find the total number of the molecules or total number of the moles, you can also say. And by using the total number of the moles, we will work out the moles of ethene. So first we have the equation PV is equals to nRT. So we'll find the value of N here. So the equation here is PV is equals to nRT, where P is the pressure. It should be in Pascal, so that is already in Pascal, so we don't have to convert. V is the volume, the total volume of the room, that is 220 meter cube, so it is already in meter cube, we don't have to convert. Temperature is there in degree centigrade, it is 21 degree centigrade, so we have to convert into Kelvin. So what we do, we add 273, so this will become 294 Kelvin. N is the number of the mole and R is a constant, which is 8.31 joule mole inverse Kelvin inverse. So we'll use the formula PV is equals to nRT, where P is the pressure, 1.01 into 10 to the power 5, V is the volume, which is 220, N is the number of the moles, R is the general gas constant, which is 8.31, and that is 294. So we'll find this N, 1.01 into 10 to the power 5 multiplied by 220 divided by 8.31 into 294. What is the value of N here? When you substitute the values, what is the value of N? N gives the total number of the moles. (1.01 exponent 5 multiplied by 220 divided by 8.31 into 294. Yeah, what's the value for N? So N will come out as 9094.9. These are the total number of the moles. But we know that the whole room does not contain ethene, only like the number of the particle and ethene. If we have 1 million particle, we only find 100 ethene molecule. So if we have 9094.9 particle, then it will be X ethene molecule. So you will cross multiply to get the value of X, and that X will be the number of ethene molecule, which will come out as 0.91 moles. Not molecule, about the mole. Is it clear, this question? That use of the equation, the general gas equation, PV is equals to nRT, and then as they mentioned in the question, that the whole room is not filled with ethene. Ethene level is 100 parts per million are used in a ripening rooms. So it's about 100 parts are there of ethene in 1 million. So if you have 1 million molecule, you find 100. So if you have 9094.9 molecules or moles, then you will have X moles of ethene. Then we have a formula for finding a concentration in parts per million. Normally, concentration can also be represented in parts per million, and it is normally used for very small amounts. So, what is the formula to get the concentration in parts per million? So, it is the mass of a substance in a mixture divided by total mass of a mixture and multiplied by 1 million. Or you can also use the mass of solute divided by mass of solvent into 1 million, or it can be volume of solute divided by volume of solution into 1 million. So this will give us the concentration in ppm or parts per million. For example, the blood plasma typically contain 20 parts per million of magnesium. So if we have a blood plasma, we find 20 parts are there magnesium for 1 million particles by mass, or 20 gram is there. If you have 1 million gram, out of 1 million gram you only find 20 grams magnesium in the blood plasma. So calculate the mass of magnesium in gram present in 100 gram of plasma. So how we can work out? So we have the formula: concentration in ppm is equals to mass of a substance divided by total mass into 1 million. The concentration in ppm is given 20, so we substituted 20 here. Mass of substance we don't know, and mass of the mixture, because we are finding in 100 gram of a plasma, so the mass of the mixture or mass of the plasma is 100. So this 100 is divided, other side it will be multiplied, and its 1 million is multiplied, other side it will divide. So we'll get 2 exponent minus 3 grams of magnesium present in the mixture. Is it clear, this example? So the formula for getting a concentration in ppm is a mass of solute over mass of solvent into 1 million, or it can be other way around, volume of solute divided by volume of solvent into 1 million. So we'll do some questions now related to parts per million, like concentration. Normally you will find in MCQs, the questions are there related to parts per million. Okay, you can see question 18. In United Kingdom, the limit of gaseous hydrocarbon in a vehicle exhaust gases is 200 ppm. So what they mention, the hydrocarbon, the gaseous hydrocarbon which are coming out from the exhaust gases can be 200 parts per million. When like 200 molecule, 1 million molecules are coming out of 1 million molecule, only 200 molecules of hydrocarbon can be there, the limit, the maximum. What is the maximum volume of gaseous hydrocarbon allowed in 10 mole of exhaust gas at room temperature and pressure? So if exhaust gas is 10 moles, so what first we have to do? We have to find, because the concentration in ppm, it can be mass of solute divided by mass of solvent or solution into 1 million, or it can be mass of volume of solute divided by volume of solution into 1 million, or it can be moles as well. So concentration in ppm, parts per million, is equals to moles of solute divided by moles of the mixture into 1 million. So concentration in parts per million is given 200 for hydrocarbon. So this is 200. Moles of solute, what is a solute? It means the solute is a hydrocarbon which are present in the exhaust gas. So moles of hydrocarbon, I'm writing in short HC divided by moles of the mixture. The mixture are the exhaust gases. So how many moles of exhaust gases are there? 10 into 1 million. So when we find the moles of hydrocarbon, so it will be 220 multiplied by 10 divided by 1 million. So what's the answer for this? The moles 220 multiplied by 10 divided by 1 million. 220 multiplied by 10 divided by, so it is 2.2 exponent minus 3. So these are the moles of hydrocarbon. So moles of hydrocarbon we got 2.2 into 10 to the power minus 3. But we don't need moles. We need volume. So how to get the volume? So moles multiplied by 24 will get the volume, because volume of a gas in dm cube is equals to moles, which is 2.23, 2.2 into 10 to the power minus 3 multiplied by 24. What's the answer? 2.2. Here, and here it is 200. I think I took 220. This is 200. So this is 200 multiplied by 10 divided by 1 million. So this was only 2 exponent minus 3. By mistake, I think I copied 220, but it was 200. 200. So 2 exponent minus 3 multiplied by 24. This will give us 0.048. But that is in decimeter cube, but all the answers are in cm cube. So if you want to convert the decimeter cube into centimeter cube, we have to multiply by 1000. So when I multiply this by 1000, 1, 2, and 3, so it will come out as 48 cm cube. So B will be the right answer for question 18. Is it clear? Discussion. Then we have empirical formula. What is empirical formula? The formula which represents the simplest ratio between the atoms present in a compound, that's called empirical formula. So the rules to find the empirical formula, what we do, we divide the mass or percentage by its atomic mass, then we divide by smallest value, and then we round off or multiply to convert into whole number. So calculate the empirical formula for a compound that contain 1.82 grams of potassium, 5.93 grams of iodine, and 2.24 grams of oxygen. So step 1 is divide by atomic mass. So atomic mass of potassium is 39, atomic mass of iodine is 126.9, and atomic mass of oxygen is 16. So when we divide, for potassium it is coming out 0.0465, for iodine 0.0465, and for oxygen it is 0.14. Then we divide by smallest value. So smallest value is 0.0465. So when we divide them by smallest value, for potassium it is coming out 1, for iodine it is coming out 1, and for oxygen it is also coming out 1. So empirical formula of this compound is equal to 1 potassium, 1 iodine, and 3 oxygen. So it is KiO3. Is it clear how we work out the empirical formula of a compound? and this already we discussed in the O levels. Then how we can work out the molecular formula from empirical formula. So molecular formula is equals to empirical formula multiplied by n. The molecular formula is equals to empirical formula multiplied by n. And what about n? N is a relative, the empirical mass divided by molecular mass. So empirical mass divided by molecular mass will get the value of n, and that multiplied by empirical formula to get the molecular formula. So in example 8, work out the molecular formula for compound C3H6NO with a molecular mass of 16. So first we work out the mass, empirical mass, which is 58, carbon is 12 multiplied by 3, hydrogen is 6, oxygen is 16. And then we find the value of n. How to get the value of n? Molecular mass. The value of n is molecular mass divided by empirical mass. So when molecular mass divided by empirical mass, will get the value of n. So in this example, it is 116 divided by 58, so it is coming out 2. So the value of n is equals to 2. So we have the formula, molecular formula is empirical formula times n, and molecular empirical formula is C3H6O multiplied by n, which is 2. So it will turn out to be C6H12 and O2. Is it clear? Then what is the difference between molecular mass and formula mass? Basically, we can use the same term molecular mass or formula mass, but there is a difference here. The molecular mass is a term which is used for simple molecules. And the formula mass is normally used, the mass, the term which is used for mass of ionic compounds. Because basically what happened, if I say CH4, methane, so I have one carbon and I have 4 hydrogen. So carbon is 12 plus hydrogen 1 into 4. So the total will be 16. So I will say the relative molecular mass is equals to 16. But if I say NaCl, sodium is 23 plus chlorine is 35.5. So the total sum will come out as 58.5. And we normally write like relative molecular mass is 58.5. That is correct, but scientifically it's not correct. Why scientifically it's not correct? Because NaCl is an ionic compound, and how ionic compound exists? These ionic compound exists as a lattice. Lattice means it is a regular arrangement of the ions. So you don't find one sodium and one chloride ion. There are millions or trillions of sodium, and same thing, millions and trillions of chloride ions will be there. So as it is existing as a lattice, we are not finding, because if I say molecular mass, so molecule of sodium chloride contain millions of sodium ion and millions of chloride ion. So practically we are not finding for whole lattice, we are only finding for part of the lattice, which is showing the simplest ratio between the atoms present in the compound. So the ratio of sodium to chloride is 1:1, and we are only working out the mass of that small unit, That's why we do not use the term molecular mass. We normally use the term formula mass for ionic compound. Is it clear? In normal question, they can use the term molecular mass of sodium chloride, but in actually it is not the molecular mass. It is known as the formula mass, which shows the simplest ratio of ions present in the structure. It is not for the full. Is it clear? So that is the difference between the molecular and formula mass. Formula mass is for ionic compound, whereas molecular mass is normally used for ionic. Formula mass is for ionic compound, and molecular is used normally for simple covalent structures. Then we can also use the ratio to calculate the moles. Like example 9, what mass of carbon dioxide produced by heating 5.5 grams of sodium hydrogen carbonate? So we have sodium hydrogen carbonate and we need carbon dioxide. So first what we did, we got the moles, because we don't know. First we convert into mole of sodium hydrogen carbonate. So moles equal mass in gram divided by molar mass. Mass in gram is 5.5 and molar mass is 84. So we got the moles, which is coming out as 0.0655. And after getting the moles, we'll use the ratio, because the ratio of sodium carbonate to carbon dioxide is 2:1. So the ratio is 2:1. So if we have 0. As a simple ratio between the two, the sodium carbonate, the sodium hydrogen carbonate and carbon dioxide, the ratio is 2:1. So if we have 0.0655, then this will be x. Cross multiply, so we'll get half of it, which is 0.0328. So we got the moles of carbon dioxide and moles multiplied by molar mass, which is 44. So we'll get the mass in gram, which is coming out as 1.44 grams. Is it clear? Example 9. Same in example 10. What mass of copper would react completely with 150 cm cube of 1.6 molar nitric acid? Capital M, it's a concentration, which means moles per dm cube. So we have 1.6 moles per dm cube, or the concentration of nitric acid. So we have the volume and we have concentration. So when we multiply concentration with volume, but volume should be in dm cube. So we got the moles of nitric acid. After getting a moles of nitric acid, we use a ratio of nitric acid to copper, because we are finding, so the ratio is 8:3. So we got the moles of the copper, which is coming out as 0.09, and 0.09 moles of copper multiplied by molar mass, so we'll get the mass in gram for copper, which is 5.71 grams. Is it clear? Example 10. So these are the moles question. Another example, moles by using a formula, by using a ratio. So what volume in cm cube of oxygen produced by decomposition of 0.532 grams of potassium chlorate? So first, moles equal mass in gram over molar mass. So mass in gram is 0.532, molar mass is 122. So we got the moles. And after getting a moles, we take a ratio of potassium chlorate is to oxygen, which is 2:3. So if 0.0043 moles are there, we'll get x moles of oxygen. So we'll get 0.00651 moles of oxygen. And then we multiply by molar volume, which is 24. So we get the volume in dm cube. To convert dm in cube into cm cube, we'll multiply by 1000, as they ask the question, volume is in cm cube. So this is a similar question. So finding moles by equation. And we can also use the ratio to work out the volume of the gases. So if we burn 500 cm cube of methane, what volume of oxygen needed and what volume of carbon dioxide given off? So we'll take a mole ratio. The mole ratio of methane is to oxygen is 1 is to 2. So if 500 cm cube is there, this will be multiplied by 2. So CH4 is to oxygen, the ratio is 1 is to 2. If this is 500, this will be X. Cross multiply, we'll get 1000 cm cube of oxygen is needed. And methane to carbon dioxide, the ratio is 1 is to 1. So if it is 500 cm cube, this will be X. So we'll get the same 500 cm cube. And keep in mind this all when the temperature is 25 degrees centigrade and the pressure is 1 atm, because that is the molar volume, which is 24 dm3. So we can use the mole ratio to get the volume. Then the percentage yield. So actually we will not get what we should get. That using this we can work out the percentage yield. So example, 25 grams of iron oxide reacted to produce 10 gram of iron. So this is a practical value. Theoretically, it should give different amount. So first, when we work out 25 divided by molar mass of iron oxide, we got the moles of iron oxide. So using the moles of iron oxide, iron 3 oxide, we got the moles of iron. So the ratio is 1 is to 2. So if we have 0.156 moles of iron oxide, we'll get X moles of iron. So when we multiply, we should get 0.313 moles. And multiply by molar mass of iron, which is 55.8. So we should get 17.48. That is the theoretical value. So theoretically, we should get 17.48 grams, but practically we are getting only 10 grams. So percentage yield is a practical value. The practical value divided by theoretical value into 100. So practically we are getting 10. Theoretically we should get 17.48 multiplied by 100. So it will be 57.2% yield. And there can be a many reasons why the percentage yield in the process can lower, because maybe incomplete reactions are there, maybe side reactions like the reactant might convert into another products, or maybe there's a loss during a transfer, or there's a loss during a purification. Is it clear? The percentage yield. So this is all about what we discuss in O level. So right now we only discuss the things. That's the reason why I quickly go through these topics, as we already completed in O level. The only extra topic which we discuss is the general gas equation and the concentration in parts per million. The topic 1 is not complete, so we have completed the term. 1.1 is done, 1.2 is there, you completed. 1.4, 1.5 and 1.6, 1.7, 1.8. Any question related to the class today? Any question or a doubt? So I'll end the session and share this recording.